Hey class, welcome to week 6. Now that we've wrapped up talking about concrete and the excuse me, the site conditions of our property, we're going to start talking about the wood structure. I have a TED Talk posted this week about timber framing, which is pretty cool and pretty interesting to think about. And this wood technology that we're going to be talking about is going to take us about 2 weeks. You're also going to be reading the chapter on metal, but I am not going to be submitting any video lectures next week for that. So there's going to be 2 lectures for our chapter 14, and then the TED Talk, plus a lot of other information that I'm going to be throwing at you when it comes to wood technology. I also want to follow up on our labs. So I'm hoping that the video worked well last week instead of trying to do it live. It seemed to cut our time quite a bit, but it didn't allow for questions. So I'm going to try to keep that process going because I haven't heard anything negative back from you guys on it. I'm sure there is some questions in regards to what I'm asking for in the lab. Hopefully it's pretty straightforward, but what we're going to do is on Thursday at that 3 o'clock hour, I will have an open session where you can join in and just ask some questions, but I won't be doing a live lab per se. I'm going to try to videotape. I'm going to videotape the information and get it up ahead of time, ahead of that Thursday. That way, hopefully, even if you don't have the other lectures watched, maybe you can focus on that lab before Thursday, just so you can make sure that if you have any questions or concerns about the lab assignment, that you're able to do that. I think by now being week 6, you should know I'm trying to give you guys enough time to be able to get the different things completed. I don't even know if I have any due dates up on our labs. I'm sure I do, but I'm sure that they're very lenient. But come week 8, so just right around the corner, week 8 is midterm grades. I will shut down all of the past labs, quizzes, review questions up until that point, because we're going to be heading into the last part of our semester. So if you have any problems getting anything in by that time, you're going to need to email me and just make sure that I know what's going on and why the delay is happening, and then we could discuss how to move forward from there. Okay, so wood technology, one of my next favorite subjects besides the foundation and making sure I have a very solid foundation to build off of, is the wood parts. So I love, as a designer, I love being able to figure out different aspects related to the framing of a project. And a lot of that for me is, yes, it's shape and what the exterior is going to look like and how the interior walls flow into the different rooms and things of that nature. But it's also about the structural piece of our buildings and where our understanding building terminology is going to be huge in this part of our course, because there's just a lot of different things that relate to the structural nature of residential construction and the wood technology. So we're going to look at different wood characteristics and qualities, things of that nature. Pressure treated wood, what's the difference, things related to that. So lumber, bid by the piece or board measure. So I typically don't do the board measure. What I'm doing, and actually I don't even do the bid by piece unless it's a small job, an addition or maybe a remodel where I can successfully, be able to count my studs in the walls, my floor joist systems, excuse me, my ceiling joists, rafters, and so on. But most of the time on new residential construction, I'm sending my lumber package out to a lumber yard, and they're bidding by the piece. They do a little bit of board measure in the lumber yards and the estimating part of the estimating division of the lumber yards, but pretty much they're going to give me a bid by piece. How many pieces I need, how many wood studs do I need for the exterior wall, so on and so forth. And I'm going to give you a sample of that in our lab folder for you just to be able to view. It will be related to the house that we're working on in our lab. Must keep sizes and lengths separate. So the sizes are always going to pretty much be the same: 2x4, 2x6, 2x8, 2x10. The lengths are what is going to change. That is your variable. And you got to be careful on this variable as far as what size, 2x4, 2x6, how long can it span per code. So all of this stuff is the IRC, the International Residential Building Code, and or your state building code. So please be very, very aware of this actual size of lumber chart. I will be asking you questions on our quiz related to this. But as you can see, the nominal size, and then you have an actual size. So why is this? Why do we have a nominal size and an actual size? The nominal size is where it starts, right? A 1x2, 1 inch by 2 inch. If you took a measuring tape and you measured it, it would clearly read 1 inch by 2 inch. But what happens when it gets to the consumer products is it goes through the mill and it goes through a process of changing and dressing it. We call it milling it down and dressing it up. So this is the rough size that we get, which is the nominal size, the true size, and then we put it through the mill and we dress it up and we come out with a 3/4 inch by 1.5 inch. And as you can see, these do change along the way. You have 3/4 inch up to, till you get to your 2x, 2x2, 2x3. Here's your 2x4 and 2x6. So a 2x6 for new construction exterior walls, you're looking at a 1.5 inch thickness of the wood by 5.5 inches. So I hope I said inches there. I can't remember. But anyways, so just understand that your nominal size is how it comes in before it gets milled and dressed. And then the actual size is what we're getting out on the job sites. The manufacturing process of the lumber is something that I definitely want you to know for our quiz. There's 3 different processes for our manufacturing process of lumber. The first one that we receive is raw material, right? Raw material is where it comes in as the log and it's brought into the mill on the truck, right? After it's logged out of the hopefully of the sustainable forest that it's grown out of. And so that is the raw materials. Then it turns into industrial goods. That's where they're dressing it and they're bringing it down to the sizes that they know they're going to be shipping out, that 2x4, that 2x6. And then all of our lengths are related to building code as well too. So 10 feet, 12 feet, 8 feet. So those are pretty common sizes that you'll see even at Home Depot. 8, 10, 12, 14. Anything above, that 14 foot usually is a specialty piece that you can only find in the lumber yards. And then even some of the lumber yards, most of the lumber yards, they don't have certain sizes over, 22 feet. I don't know. I'm just coming up with that 22-foot number. Don't quote me on that. But sometimes they might have to ship out and get a specific length to, I was just working on a project and it was a rafter length and it was 31 feet that were spanning a 2x10 rafter. I have different point loads in that 32 feet, meaning I split the load coming down on there at 12-foot increments. So at every 12 feet vertically, I'm coming down with a post and I'm posting down onto an interior wall. That's what I'm talking about, the structure. Really figuring out the structural details of wood construction is just very intriguing to me. Okay, so industrial goods, and then it comes into the consumer products where we go pick it up at Home Depot, or hopefully you're going to the lumber yards and it becomes a consumer product. So the manufacturing process of wood is raw material, turns into industrial goods, which turns into consumer products. In your book and in this PowerPoint, you can read a little bit more about board measure and how to be able to do that. I'm not going to get too specific into that in my lectures and lab because there's a lot of material to go over, and I want you to get the most out of this as you can. So please read through that in your book. Floor framing. So your floor framing, these are, again, that building terminology that I had said, that's going to be really important for you to be able to understand. And you will see pictures related to these. So I can't stand it. Again, I'm using the book here for my PowerPoint to be able to send this to you so you have some really good information from the textbook. But I will have a nicer picture related lecture for you for the lab that's going to show you what all of these different things are, okay? Because a picture says 1,000 words as well. But your floor framing is going to include the girder, the sill, the floor joists, joist hangers, and subflooring. Okay, and your floor joists are going to be related to specific sizes and lengths, spans we call them, that they can span before they get to the next girder and or point load. Okay, so this is a good representation of a cross section. Here are our foundation walls on the outer edge. And then the first thing you have that's going to be touching your foundation, they're not showing it here, but we actually roll out seal. So it's just like this foam moisture barrier, and we put it down under this sill. This sill is a pressure treated piece of material. It's pressure treated because any wood touching concrete or the ground has to be pressure treated, right? We can't be putting pressure treated in our exterior walls, but we have to be able to have some kind of a moisture barrier to wood when it's touching concrete, because concrete will always whisk moisture. Here's your girder. This is your beam. This is your carrying beam. I typically don't call it girder, so this could be girder / carrying beam. And that's what it is. It's a carrying beam. And you can see we have a split in our floor joist system. And this is the span that I'm talking about. What is this dimension from the outside part of our foundation wall to the center of our girder / carrying beam? What is this length? Pretty classic 2x10 floor joists will span up to 15 feet. And we go to our code book to be able to see this. Does it have it here? Yep, joist span table. We have different, no, this isn't the joist span table I was looking for. Never mind. I'm going to back up a little bit. And we have joist span tables that I will put up in our course content folder that'll show you exactly what it looks like right from the code book. And it's pretty typical to do 16 inches on center. So that means from this floor joist to the next floor joist is typically 16 inches on center. And then you can see this little piece of wood kicking up on either side here. That's bridging. And we crisscross bridging in between our floor joists, just so nothing buckles, okay? Joist header. So your joist header or your joist box, we'll call this as well too. There's a few words that are interchangeable. I know I said these are building terminology words. So when I say the other word that's not shown here, that's pretty true to building construction related terminology, okay? Joist hanger or joist box is it just kind of boxes out that floor joist system, okay? And then your plywood goes on top of the floor joist, and then your finished floor is going to go on top of this plywood. Of course, if it's hardwood, you're going to put down this felt paper. If it's tile, you put down cement board or some other type of waterproofing material before on top of this plywood here. Okay, so the sill, the quantity is often the same as the perimeter of the building. So they're talking about the linear footage of the building. We just did our linear footage of our foundation footings and walls, right? So with your wall, you could figure out what the quantity of your sill would be. That might be a good question for your lab assignment. So naturally durable or treated wood. So again, this is a pressure treated piece of material since it's going against that concrete, and it's going to be close to the ground as well too. So you think about splash coming up, right? Rain, sleet, all those different elements that we have. That's going to bounce off the ground and come up towards that wood piece. That's the first wood piece that it will touch. A wood I-joist. So this is the specifically I-joist systems. So they're 2x6, 2x8, 2x10, 2x12s. That's our typical lumbers. And then we have I-joist systems. I-joist systems pretty much look like an eye. Okay, you can see that this is a web stiffener on either side of it, but this top part and this bottom part are called the flange right here, the flange. And then the web is actually, you can see it on the profile here. It's this thin piece of material and it looks like plywood, really what it is. And it creates a very, very, very strong joist that can span much further than any of these typical lumber. So this is a man-made product, right? And we engineer it specifically to span longer sizes. The problem with I-joist, great, that's the positive. We can span 20 feet, 22 feet, 23 feet, 4, whatever, without any girders, any carrying beams underneath it. Negative is this burn rate. If this floor system was to catch on fire, this web is full of glue and wood particles put together, and hence what creates the strength. It's compressed and put together. The flange helps create the strength as well too. But it's almost like a match, really. It's very thin and very flammable. Okay, so these I-joist systems, over the years of testing and fire departments, advocates, things of that nature, what they've required us to do about 5 years ago is actually put a fire resistant material on these I-joists when used in residential construction. We automatically do it in commercial construction because every floor has to be fire rated. But within the residential world, we typically don't have to do that from basement to first to second. But when you use these I-joists, you definitely need to do that. So one of the ways you could do it is by using 5/8 inch drywall on your ceiling, or you could use Roxul insulation, which is a wool insulation, fire resistant material. And or in the factory where they make these I-joists, they actually spray the web to protect the web to give it a longer fire rating classification. And that is super, super expensive. So I typically stay with the 2x10, and I use an engineered carrying beam, so I don't have as many lally columns. Those are the columns, those 3.5 inch columns in your basement, right? Typically underneath your beam. And so I to decrease the amount of those, I'll use an engineered beam, an engineered carrying beam, but then I'll stick with my 2x10 floor joists. So it does, it's definitely saving me costs by not going to the I-joist system for the cost that it takes to create these engineered beams that we can use in residential construction. Okay, so this is the divide length to be framed gives a, yeah. I'm going to give you a much better joist spacing table from the code than what's in our book there. So then we have some single trimmers and headers. This is when we're opening up a part of the floor joist. Typically, this picture right here would be, to me, it would be an attic scuttle. So this would be going up into an attic area. So you're just really framing it out. The trimmer, single trimmer, is kind of like a beam, so to say, carrying these header pieces over. And then your joists are just connecting right into those header pieces. We can also double these up depending on the size. You can see it's over 4 feet when we have to double up those trimmers, and less than 4 feet, we could just use single. So the single ones would be, again, when I'm going up into an attic scuttle that I have to put on a second floor into the ceiling space. The double trimmers and headers, this would be more of, this opening would be for the staircase. Okay, so that's when we double things up because we're increasing this length here. And I'm sure I could find somewhere a chart, there's only a certain distance that even this can go with these double headers. There's charts all over our code book. Here it is in plan view. So you can see where the headers are. You can see the dimensions for your spaces and the floor joists that are being taken out to create these openings. Another opening that could be is a pull down staircase for an attic as well too. That attic scuttle I said. Attic scuttles are very simple openings, such as the picture on the left, very small. You put a ladder up there, you climb up through. There's really not much going on up there. You're just checking for things, right? It's just an access panel. By code, we have to have that. Those pull down stairs, though, up in an attic, if anybody's ever seen one, or maybe you have one, is you actually pull a large piece of material down from the ceiling, right? And you have a set of staircase that's a ladder, so to say, that is within that opening that you can actually go up. Maybe there's storage up there in the attic area. So depending on the size, depending on what's going on for it, is the difference between having, sorry, I was talking and looking at this picture at the same time. Here's an extra triple joist, 3 required. We're at 8 feet opening here. So this is an 8-foot opening by 3-foot opening. So again, charts everywhere for the different sizes and materials that we have to use. Bridging, this is classic bridging right here, cross bridging, where you're going to see these crosses of 1x all over the your floor joist system if you're in the basement looking up. They also have metal bridging that you could use. I have not used metal bridging in my time of building and designing. I have used cross bridging quite a bit. And then solid blocking I've used quite a bit as well too. So these top 2 examples right here. Solid bridging, you want to put anywhere that you have a structural load coming from above down to this this floor joist system right here. Plywood, so this is not a wall. We're looking at this in plan view, and you can see it. This is just representing the sizes of the pieces of plywood, and we do bid by the sheet on here because, as you can see, we can take our floor plan and we can figure out different square feet per by the sheets. Sheets are 4 by 8. And you can either draw it out, or we could figure out the square foot of these and figure out how many you need per horizontal and vertical, the 6 full sheets up, right? That 24 by 50. So we bid by the sheet because that's how we buy them. We buy them in by 4 by 8 sheets. And then just one other thing on the plywood layout. I may repeat myself on the lab lecture part of things because I'm going to be showing you the house plan. So I may point out some other things if I can remember to relate this lecture to my lab lecture. But so just a heads up, I may be repeating myself. What else was I going to say about the bid about these sheets? Oh, there's certain nail patterns that you have to do. We glue these down, nail them down, screw them down. And there's certain patterns that you have to be aware of. And there's certain spacing that you have to be aware of when you're laying these down as well too, per code. Another great piece of information is going to be the wall framing in your book. Excuse me. This is 100% total quiz worthy material right here. So it's really important for you to be able to know these words and where they belong, such as your double plate. So this is a framed wall. Interior or exterior, doesn't matter. We use double plates on the top. We use one single plate, which is called a sole plate. So think of the sole of your shoe. It's the sole of our wall, right? That gets attached to the, if this is an interior wall, it's getting attached to our plywood sheets. Okay, so your sole plate. This is a wall opening, so this is a door coming through this wall, and you have a header. You have a header above windows and doors. The header size is all dependent on the width of the door, but it stays pretty typical. 2x8 is a pretty typical one. LVL beams, which is a laminated beam, we have to start using when we get over openings. I believe it's 4 feet. I'd have to look in the code book, but I'm pretty sure that it's 4 feet, and then we start using LVL beams. And then your finished material goes on top of this. Obviously, insulation would go in through these studs in an exterior wall. Interior wall, not so much, unless you want a sound barrier in between two rooms. The studs, so we call our 2x, we call them studs. 2x6 is going to be for the exterior walls, and 2x4 is what you're going to use for interior walls. Why is the difference? 2x6, you have a 5.5-inch depth, right, from front to back. A 2x4, I only have 3.5 inches. So I actually have 2.5 inches more of insulation that I can use. Our insulation values we'll talk about a little bit later on in the semester. But for an exterior wall is R21. You could never get an R21 fiberglass, at least, in a 2x4 wall. You'd have to use a spray foam or some other means. So why we have the difference there. 2x4 in the interior will save a little bit of cost, right? As long as you're not putting any insulation in between it, should be fine. Actually, I put insulation in between 2x4 too, no big deal. For the sound barrier. Not all insulations work for sound barriers though. And again, we'll get into that later on in insulation. So this is the 16-inch on center. So from the center of this stud to the center of this stud would be 16 inches on center. Classic 16 inches on center. Studs, 2x4, 2x6. Okay, know those, please. Bottom plate. So this part of the lecture is just talking about those bottom plates. We could bid by the piece, linear foot, board foot. This is just going through and talking about how to be able to do this. Double top plate, double sole plate. Let me think. Oh, if we want to increase the ceiling height. I was like, why do we do a double sole plate? Oh, yes, to increase the ceiling height. If we just use the one, you know, we do cut these plates, these 2x out, obviously, once we're done framing and such. We don't want a little step there going in between doors of rooms and such, right? But if you want to just raise up that ceiling just a little bit, right, that 1.5-inch space makes a difference when you're dealing with 8-foot ceilings. If you have an 8-foot ceiling and you start putting drywall and things of that nature right up in there, it's going to start decreasing that ceiling height. So sometimes we put double sole plates, not all the time. Okay, so your studs should be separated into various sizes and lengths. You're going to see this on the lumber material list that I send you. Everything is separated into the various sizes and lengths. Estimating. So what you're doing is you're reviewing the specifications, seeing if there's anything different. Do we need to add that double sole plate to raise that ceiling just a little bit? What's going on, right? Because you want to be able to, well, actually that was the sole plate. This is the studs. But is there anywhere that it could be 12-inch on center? Is there anywhere that, you know, there could be something different? Add extra studs. You want to add extra studs in the corners. So I'm going to show you how to do a quick wall calculation, and I'm actually going to have you do a wall calculation in our lab for this week. So what you're going to do is you're going to divide the length by the spacing. So if I give you a 50-foot length and I want 2x6 at 16-inch on center, 16-inch is your spacing. So we're going to figure out how many studs it would take for this one wall. And I'll probably throw in some openings there just to throw you off, of course. So the other thing with openings, let me go back to that real quick. Two things that are not on here. So I'm going to have to do another picture diagram of this because there's two other studs words that aren't on here. And maybe they'll be on the windows part of this lecture. I don't know, but see where the header is and see how there's a stud underneath the header. Well, that's your jack stud. So your typical studs that go from your double plate to your sole plate, that's a stud, plain and simple. Your jack stud is actually under the header. And then you have a king stud that's attached right on top of that jack stud, right? They're right next to each other. They're connected to each other. And it connects to the header. So this whole assembly becomes one solid unit, right? You have your jack stud underneath holding up the header. You have your king stud just holding everything together. So again, I'm going to add jack stud and king stud to part of your quiz in representation of this picture. And I'll get another one in the in our course content information. So this slide is going to be important for your lab assignment. Actually, you want to add extra studs for corners, wall intersections. So if an interior wall is coming into your wall, you need to be able to add extra studs for that. And then of course your wall openings for your jack stud and your king stud. And then of course gable ends. So if you have a gable roof, which I'm not going to get into on this lab, don't worry. We add extra studs for that as well too. This is a great corner stud detail of how this gets framed. And then you also have an interior wall coming into an exterior wall right here. One important thing, if you notice this little space right here, so where the 1 and the 2 is, this would be the exterior part of your wall. Obviously, this inside part would be the interior part of your wall. This space, this is a void right here, and this could cause some serious air leakage. So as a habit, I always had a roll of insulation, of fiberglass insulation on the job site. If not two, obviously, depending on the size of the house, you want to make sure that the framers that you're working with have insulation and that they are filling these voids. Before they put that interior wall up here, they're filling this void with fiberglass insulation. Once your exterior sheathing goes on the outside, you're not going to know if it was put there or not, right? Until you do your blower door test at the very end, where they suck all the air out of the house and they find out where these leaks are. Well, guess what? Right here, this is a perfect spot for air leakage if there's no insulation in this cavity. This is the picture of the gable wall. So if you had a gable wall here, this is where we're adding extra studs just to be able to fill this in. So our exterior material can then be attached to something. This is 25. Okay, I'm going to stop this video right here. Actually, I'm going to go for 2 more. So this is what a header looks like. Again, this book does great representation of cross sections and pictures just to be able to visually show us. I'll also show you this on our lab lecture, but it calls out the 2 2x10s, a 2x4 down here, trim piece, plywood spacer. This creates an extremely strong header, actually, when you put plywood in between 2 2x10s. It's called a flinch beam. So it's 2 pieces of, excuse me, a flinch beam is a metal piece that's in the middle. This is a plywood piece that's in the middle. Flinch beam is when you do 2x10s, 2 2x10s, and you have a metal piece of material that spans your header, creates an extremely strong header. Plywood does as well too. Cripples, that's another word that is going to be on our quiz. I'll get you a better representation of a framed wall with a door and a window in it that I just realized I have. And I will make sure that all of these different labels are in here too. So these cripples are what are above and below a window. This window in particular does not have a header, because if you have a window that's underneath a gable like this, there's not any weight coming down that's going to require you by code to put a header above a window. The point loads are on these sides where these rafters are coming down. And if there's a wall where these lines are, that's where your point loads are, not necessarily in the middle of a gable here. So sometimes there it calls out for not having to do a header. And then this is just another OSB. So this is plywood in between two pieces of material. Again, just creating that much stronger beam to be able to span a little bit further. Okay, I'm going to wrap up this lecture right now on this one, and then I have a whole nother half-hour lecture minimum to do for the rest of this slideshow, this PowerPoint presentation for our book. That's why it's taking us 2 weeks to get through this. All right, thanks guys. See you on the next one.